Welcome back, guys. We are doing Chapter 6, last part of Chapter 6 on methodological control and experimentation. Up to this point in Chapter 6, we've talked about the difference between subjects and within subjects research, what the differences are between the two. And the last thing I left you off with was the idea of carryover effects. That is, since within subjects of repeated measures research, each participant is going to be doing the task twice. Again, in the simplest case of one independent variable and two levels, they're going to be doing the task, one time with one level of the independent variable, then another time with the other level of the independent variable. So some things can happen between, just because you've been exposed to the task once, that may affect your performance on the task the second time. That has absolutely nothing to do with your independent variable. Okay, so what are some of the things that you have to consider when you're doing within subjects research? Well, the biggest one is to actually do different treatment orders. Okay, so in the simplest case, okay, let's say again we have two levels of one independent variable. Let's go with social facilitation again. We've been sort of working that one through this chapter. So in one level of the independent variable is that you're watched by 0 people or no one at all, and then in the second level of the independent variable you're watched by 2 people. Okay, and we want to see what the effect of being watched is by X number of people on your performance. Let's say that performance is a maze task. You have to do a maze, a little paper maze. All right, so what you need to do is again counterbalance the orders. Okay, so in the simplest case, like I said, we have 2 levels, A and B. A can be watched by 0 people. B would be being watched by 2 people. So that would be the one treatment order that you could do. Okay, but obviously, we wouldn't know if there are any carryover effects or not in that particular case. So the best thing to do in this particular case, if we are deciding to do within subjects, we just counterbalance the order, and we then do the other treatment order that we can label BA. All right, so half your participants are randomly assigned to get A, then B, in this particular case watched by 0 people, and then 2 people. Or the other treatment order is that half your participants are watched by 2 people first, and then the second go around they're watched by 0 people. So now those treatment orders are totally counterbalanced. Very simple with just 2 levels, and hopefully I don't have to talk about this too much, because obviously this makes a certain amount of sense, right? Okay, now if there are any sort of carryover effects, they're sort of smoothed out between the 2 different treatment orders. Okay, so again, if we had 12 subjects, 6 would be randomly assigned to do A, B. The other 6 would be randomly assigned to do B and A in that order. Okay, another possibility is for each participant, you do A first. Okay, in this particular case, 0 participants, 0 people watching you. Then you do 2 people watching you. Then 2 people watching you again, and then 0 people watching you. So you get A, B, and BA, but all in one get-go with one participant. Again, this is called A, B, BA. This is not ABBA. Do not confuse that with the Swedish pop supergroup. Do not start singing Dancing Queen in your head. Do not do it. It's not my responsibility if you get Dancing Queen stuck in your head. Okay, thank you very much. All right, so simple with 2 levels of the independent variable, right? Okay, how about 3 levels of one independent variable? Gets a little trickier, but not too bad. Okay, so let's take the example again of one of the first articles I had you read was how wearing eyeglasses could affect the intelligence level or the profession of the person wearing the eyeglasses. Okay, so let's take a little what's next version of that. Let's say we have our target person wearing glasses, and we want to see if the type of glasses worn affects that intelligence level. So we have people wear either Valentine-shaped glasses, okay, or just regular wire frames, okay, or we can have people wear vintage, heart-shaped glasses. I should put that, and then vintage glasses. So these are 3 different levels: heart-shaped glasses, wireframes, and some vintage-looking glasses. All right, so that would be one of our treatment orders. All right, so what would be the other treatment orders? Well, if we keep H in the first position, the heart-shaped glasses in the first position, then we just move these around. Then we have HVW as our next ones. Okay, so that actually taps us out with having the heart-shaped glasses in the first position. Okay, how about if we put the wireframes in the first position? Well, there's two possibilities there. There's WBH and WHV. So now we've got, the W in the first position, the wireframes tapped out. Okay, so what else can go in the first position? Well, would be the vintage glasses. So we'll put the vintage glasses in the first frame. Okay, in first position. Okay, then we have VHW and VHW. Okay, actually, I did, whether it's the mirror image or not, that's why I used WH and V, so it would be the same forwards and backwards. Okay, but now we've got 6 different treatment orders, right? Okay, and that taps us out. Those are the 6 different possible treatment orders when you have 3 levels of the independent variable. All right, so that's it. Okay, so you have 3 levels. How do we know, or what's the rule of thumb for how many treatment orders do we have? Okay, when you have 3 levels, it is 3 factorial. Okay, so if you remember back from your high school math days, what does factorial mean? You take that number and you then multiply that by that number minus 1, then that number minus 1 until you get to 1. So 3 factorial would be, okay, let's go this way. Okay, 3 times 2 times 1 equals 6 different orders, and that's what we just showed to ourselves. There's the 6 different treatment orders, so each person gets randomly assigned into one of those 6 different treatment orders. Okay, so again, if you had 12 participants, 2 people would be randomly assigned to each one of those different treatment orders. Okay, how about if you had 4 levels of the independent variable? How would we do that? Okay, well, we have 4 factorial now. Okay, so what's 4 factorial? 4 times 3 times 2 times 1. 4 times 3 is 12. Times 2 is 24 times 1. So you actually do have 24 treatment orders when you have 4 levels of the independent variable. You can actually do the same thing if you have a little time on your hands. You can actually do the same systematic way that we did that with the 3 levels. Put one of the conditions in the first position, and then take the next 3 and loop them around. Okay, and you will find that there are 24 different treatment orders there. So in order for this to be a completely counterbalanced design, you would actually have to have 24 different participants, and each one is given one of those 24 treatment orders. All right, so far so good, I think. So again, you probably won't be dealing with any more than 4 treatment orders, certainly in this particular course, and maybe not in your next couple of courses either. All right, so the other thing that you can do that's mentioned in the book is what's known as a Latin square design. Latin square is, again, another way to try to ensure that an equal number of treatment orders is done for each participant. It's a little complicated. I don't think it's anything that you guys need to really worry about the nuts and bolts about doing right now. So I'm just going to leave it for you to know that it does exist. It is something that I think you should be aware of, but I don't expect you to be able to actually do that right now. All right. The other thing that has to be considered if you are going to do within subjects research, and you're worried about, again, this idea of any of these carryover effects, a couple of different things you can do. Okay, one would be if you're worried about fatigue. Okay, so if you want to, if you think that task is going to make the person fatigued too much the first time, you just give them a nice break in between. Okay, there's no reason you have to do the tasks right after each other. Okay, so if you give it a little break, then any sort of effective fatigue might not be be that prevalent. All right. The other thing you can do is make the task simpler. So again, if you're worried about fatigue, make the task a little bit simpler. That way, they're not exhausted after each time that they do it. Okay, so making the task simpler is another way that you can deal with at least fatigue. The other carryover effect that we mentioned earlier was learning. If it's a learning task, one of the tasks that I had people do, when I was working on cognitive research in what's known as a short-term visual memory, we presented digits at a very rapid rate. Okay, so we asked them to see whether they can find a repeated digit in a stream of 30 digits. So the number stream would be like 1799832. So they'd have to detect that 7 when it was repeated. Well, we were doing this at a very rapid rate. We were presenting these at 9 per second. Okay, so it's very rapid, but it takes a lot of practice to get used to it. So what we did was make sure that we practiced the subjects enough so any of the manipulations that we made weren't due to learning. So this is what we talked about in terms of going to asymptote. You do the task enough, so again, if it's a hard task, they're not going to be able to do it very well the first time, but they start doing better the second time, third time, fourth time. So they are learning they are learning the task, but at some point their performance is going to level off. Okay, so that learning curve is going to level off, and this is what we call learning to asymptote. So whenever there is a change in the level of the independent variable, it's not due to the learning, which is down here. It's going to be due to whatever the task is learned as good as it's going to be. So any change in the dependent variable is going to be due to your manipulation. Okay, so that's what we were talking about in terms of learning to asymptote. Okay, all right. The last thing that you can do is actually make treatment order an independent variable. So if you're really worried about whether are these treatment orders, you make treatment order an independent variable, and you make that a between subjects variable. Now what that does is make your whole design a mixed design, which is something that we're going to be talking about in chapter 8, okay, where you have two independent variables, and they can either be both between or both within, or you can have a mix of them being between or within. Okay, so that is all I really want to talk about in terms of the difference between subjects and within subjects. The other thing that's mentioned in this textbook is in this chapter in the textbook is the idea of longitudinal research. So basically, you can use those same ideas about within and between subjects research in longitudinal studies. So if you want to know the difference between 5-year-olds, 7-year-olds, and 9-year-olds, well, you can do what's called a cohort design, where you take 5-year-olds right now, 7-year-olds right now, and 10-year-olds right now, and then you test them. Or if you want to see what the effect of these different ages are, you take a group of 5-year-olds right now, you test them, you have them come back 2 years later when they are 7-year-olds, then you test them, and then you can have them come back 3 years later when they're 10-year-olds. So that's a longitudinal design. So that essentially is basically the within subject type of situation. Okay, you can also combine the two. All right, so you can actually have this combined design. So again, it's nothing really major new. Okay, it's just how they specifically do that in a lot of developmental research. Okay, all right, so that's all I have for this part of chapter 6. I'll do one more part of chapter 6 that deals with the different types of reactivity and demand characteristics and experiments. So take care, everybody, and I'll do the last portion very soon. Great, take care, stay safe, stay healthy, and we'll talk to you very soon. Bye-bye.